Welcome back to The Explainer. Today, we're diving into something that looks kind of simple at first glance, but is honestly an absolutely critical component in professional electrical engineering. We are talking about the humble plastic wiring duct. It's the unsung hero hiding inside almost every industrial control panel, and mastering how to use it is literally what separates the amateurs from the true professionals. Picture this for a second. You pop open a control panel, maybe hoping to quick fix a faulty relay, right? But instead, you are staring at an absolute spaghetti nightmare of wires. The kind of mess that makes you just want to slowly close the door and pretend you saw absolutely nothing. Look, we've all been there, and it is a visceral pain point. But here's what we really need to understand right out of the gate. Professional cable management isn't just about making things look pretty. It's fundamentally about safety, protecting signal integrity, and ensuring that future troubleshooting takes minutes instead of hours.
So, here's our game plan for today. We'll start with why wiring ducts matter, then look at choosing the right type. After that, we'll hit the math behind sizing and fill ratios, plan out the perfect panel layout, and finally, wrap things up with cutting techniques for a pro finish.
Okay, part 1. Why wiring ducts matter, beyond just holding wires. Let's get right into it.
So what are we actually dealing with? At its core, a wiring duct is an extruded plastic channel. Usually, it's made of PVC, nylon, or a halogen-free plastic. It lives inside your enclosures to route, protect, and organize all that internal wiring so things don't just flop around uncontrollably. But here's the kicker, and what's really crucial to understand, it does not replace your circuit protection, and it is definitely not a substitute for proper wire insulation. Instead, think of it as a comprehensive containment system. It dictates the entire internal flow of the panel, keeping your loose conductors safely away from moving parts, sharp edges, and hot components.
I like to think of this routing like a bustling city grid. Your delicate analog signal wiring, those are your pedestrians. Your 24-volt DC control wiring, that's your local street traffic. And your heavy 230 or 400-volt AC power wiring, well, that's your heavy highway traffic. The golden rule of city planning, and panel building for that matter, is that different traffic needs different roads to prevent collisions. In our world, those collisions are electrical noise. Physically separating these distinct circuits into different channels drastically cuts down on noise transfer from stuff like VFDs or contactors. It's what keeps your machine running stably. Moving right along to part 2, choosing the right duct type, specifically slotted versus solid wall.
The main difference between these types really boils down to the sidewall design, which tells you exactly how and where you should use them. Slotted wiring duct gives you incredible flexibility and super fast installation. It's your everyday go-to for general panels. Why? Because if a wire needs to move during commissioning, you just pop it out of a different slot. No sweat. Solid wall duct, on the flip side, is totally closed off. It offers maximum physical protection, keeping dust and stray wire ends out, and honestly, it just gives off a premium, ultra-clean vibe. You'd use this for highly sensitive signal routing where strict physical discipline is a must, and for layouts that you know for sure are never going to change.
Now, if you do go the slotted route, you've still got a choice to make. Narrow slot ducts have these small fingers. They are fantastic for neat, individual wire exits, which makes them absolutely perfect for PLC I/O and standard smaller control devices. Wide slot ducts, though, have much bigger openings. This lets you route thicker bundles or heavier gauge wire right out of the channel without subjecting them to tight, damaging bends. Perfect for high-density motor control and variable frequency drives. The pro move here? Panel shops rarely stick to just one type. They mix them up. Wide slots near the heavy contactors, narrow slots by the delicate I/O modules, keeping the whole setup practical and orderly.
Which brings us to part 3, sizing and wire fill ratios. This is the math behind the layout, and honestly, it's where a lot of people make completely avoidable mistakes.
Look, picking the wrong width and depth will absolutely wreck even the most beautifully planned layout. Before you drill a single hole, you gotta do the math. And here's the absolutely critical detail. You must calculate using the conductor's outside diameter. Yes, you have to account for the insulation. If you just calculate based on the bare copper size, you're gonna end up with a massively overfilled duct every single time.
And getting that calculation right leads us directly to this golden number right here, 50 to 60%. That right there is your ideal fill ratio target.
Check out this breakdown. You see that 50% empty space? That is not wasted room. It's actually a highly deliberate engineered feature. If you pack a duct to 100% capacity, you're creating a severe heat trap. On top of that, you literally won't be able to snap the plastic covers back on when you're done. Plus, leaving this open volume gives you the breathing room you need for future service additions when the machine inevitably gets upgraded down the line.
To give you an idea of how this translates out in the real world, here are some standard metric sizes. A small 25 by 40 mm duct is perfect for tight spaces, like small panels, delicate signal wiring, or running along the inside of cabinet doors. Step up to a 40 by 60 mm, and that's your daily workhorse for general control panels and PLC cabinets. But when you hit those massive 100 by 100 mm ducts, you are looking at high-density motor control centers, drive panels, and main automation wireways.
All right, part 4, planning the perfect panel layout. This is where your blueprint really comes to life.
It's super important to understand that duct planning happens in the mechanical layout phase, long before you even strip a wire. If you wait until the end, you're going to force wires into terrible routes. The sequence is simple, but you gotta be strict about it. Step 1, map out your routing grid. Horizontal ducts top and bottom, vertical ducts along the sides and between major device groups. Step 2, and this is huge, leave at least 25 millimeters of clearance from the edge of the duct to your component terminals. Jamming the duct right up against a relay blocks the terminal screws and covers the labels, making maintenance a total nightmare. And step 3, bring back that city grid analogy. Physically separate your 24-volt DC control wiring and your heavy AC power into dedicated, distinct runs.
Finally, part 5, cutting techniques for pro finishes and making sure we protect that PVC profile.
Once your layout is locked in, you gotta cut the plastic. And trust me, cut quality matters. Cracked PVC and rough, burred edges are safety hazards. They chew up wire insulation, and honestly, they just look awful. This table shows exactly why your tool choice is a big deal. A dedicated guillotine cutter, top-tier quality with almost zero risk of cracking. It's a must-have for pro shops. A fine-tooth handsaw is decent for low-volume fieldwork, but it comes with a bit more risk. But a utility knife? No way. Reserve that strictly for tiny, light trimming corrections. Try hacking through a thick duct with a utility knife, and you're just asking for an uneven edge and a nasty cut on your hand.
If you are building panels day in and day out, you absolutely need to invest in a product cutter. You're looking for a guillotine shear mechanism that supports the plastic during the cut instead of twisting it. You definitely want built-in length stops so you aren't pulling out a tape measure for every single piece. Make sure it's got the capacity for the widest and deepest ducts you normally use. And please, check the handle ergonomics. If you're cutting duct for an 8-hour shift, comfort really matters. Honestly, the time you save with one of these will literally pay for the tool in a few weeks. To bring this all together, let's talk about international safety standards like UL 508A and IEC 61439. They do not make neatness optional in practice. Actually, let me say that again. Neatness is not optional. These standards actively push panel builders towards safe spacing, protected wiring, and repeatable workmanship. What we've been talking about today isn't just for making things look pretty on Instagram. Proper cable management, exact wire fill ratios, and clean cuts are literal regulatory requirements that inspectors are looking for. Having organized ducting proves to the inspector and your client that the panel is built to a serious standard of safety.
So, as we wrap up today's explainer, I want to leave you with a question to chew on before your next project. How do your current control panels measure up to these pro standards? Are you really respecting that 50% fill rule? Are your signals properly separated? Take these systematic lessons and apply them to your very next build. I guarantee you'll see a massive difference. Thanks for hanging out with me on this explainer, and I'll catch you on the next one.